Okay guys, we're looking at section 3.2. This is the second day of it. We have some space on page 52. You should have some open space here in the middle to add in a couple of problems. If you don't have any space, find some space somewhere. Alright, so the first problem we're going to look at is this. X squared plus 9 equals 0. Everybody's done x squared minus 9 equals 0, because we could factor that, couldn't we? X squared minus 9 equals 0 is just x minus 3x plus 3, so our solutions are 3 and negative 3. But what about x squared plus 9? Well, here's what we do. We're going to subtract 9 from both sides. We now have x squared equals negative 9. I have to take the square root of both sides. So I get x equals, anytime I have an equation and I take a square root, I must put plus or minus. What's the square root of negative 9? 3i. So these are going to be our solutions. Positive and negative 3i. I want you to just watch when I do some things here on the calculator. If the problem had been x squared minus 9, here's the way it would have looked. Can you see our zeros right here at 3 and negative 3? But watch if I put in x squared plus 9. Here's the way it looks. There's our x squared minus 9. Here's our x squared plus 9. Remember how that would be a shift up 9? Shift up 9. So does it have any place where it equals 0? No. And that's why we get these imaginary solutions. So anytime we have an equation that's been shifted up so much that there are no places where it crosses the x-axis, then we don't have any zeros. We have imaginary solutions. Now, back when you were in Algebra 1 doing this problem, you would have said no real solutions, which is true. However, there are solutions. It's just that those solutions are imaginary. Are these pure imaginary? Yeah, they are. Pure imaginary just means there's no real component. So the A part is actually 0. So these would be pure imaginary numbers. All right, let's do this one now. So we would do the same kind of thing. We take the square root of both sides. So x equals, I have to think of numbers that multiply to be 20. Those numbers would be 4 times 5. Because I have an equation, I must put plus or minus. The square root of 4 is 2. And what else am I going to have to put out there because of the negative? So it's plus or minus 2i radical 5. Does it make sense that we have two imaginary solutions? Is this ever going to equal 0 as far as thinking of the graph? Because it's a shift what? Up 20. It's never going to be crossing the x-axis. So that's why we have the imaginary solutions. All right. Page 53 has nothing for us. We already did all of those. So skip on over to actually page 55. Solve the equation. Check your solutions. Okay, I'm going to be working these at the same time you are. Okay, well, mine must have just printed out wrong, so it's on page 54. All right, so to do this then, we're going to have to take over the 25, or let's go ahead and take over the 5x squared, actually, that's easier. So negative 5x squared equals 25. We have to divide by negative 5, and then take the square root. It says to check your solutions, but all that would mean is that I have to plug in I radical 5 and square it. Well, if I square I get I squared. What's I squared? Negative 1. What's radical 5 squared? So if I do 5 times negative 5, what do I get? Negative 25 plus 25, does it work? So I'm not going to make you show that check. Just kind of doing it analytically there, just mental math. All right, let's go ahead and do this one. Do it on your own. You can watch up here if you get stuck, but I think you'll be fine. Did you get it right? Good. All right, let's do this last one now. I would eliminate the fraction first. Guys, on this last one, I always see people do 15 times 4 and then divide by 3. Why is it better to do 15 divided by 3 and then times 4? What's it do when we divide? It makes our number smaller. Isn't it easier to do 15 divided by 3 is 5 and then times 4? That's easier. And when we divide by negative 25 here, I can put this negative anywhere. It can go on the bottom, it can go in front of this fraction symbol, or it can go on the top. I always like to do this. I always like to just put it on the top. I think it just makes it easier to work with. So when I divide a positive by a negative, I get a negative, and I can then put that negative in any spot. I always choose to put it on top. And now take the square root. So I'm going to get x equals, because of the negative, I know there's going to be an I. It must be plus or minus I radical 3 over what, though? What's the square root of 25? Just 5. I don't need a radical down there. So look again. I had an equation. That's the plus or minus. I had a negative. That's the I. Square root of 3 I can't do. Square root of 25 I could do. All right, let's look at this last problem. It says sketch a graph of a function that has 2 real zeros at negative 2 and 2. Then sketch a graph on the same grid of a function that has 2 imaginary zeros of negative 2i and positive 2i. Explain the difference in the graphs of the two functions. Okay, so I want you to do that. But then I also want you to do a little bit more. I want f of x, I want you to write the f function that has these 2 zeros. So I want to know exactly what is that f function. And then what would be another function, g, that would have these 2 zeros. Okay, so try it. Feel free to check with your partner. I'm going to call in somebody here in a second. Okay, Olivia, what did you put for your f function?
X squared minus 2.
Okay, so I'm going to check that. The way I'm going to check it is I'm going to graph it. So remember how it had to have two real zeros of -2 and 2? Right here's 2 and right here's -2. If I look at my table of values, at -2 I should have a 0, and at +2 I should have a 0. So that's not quite right, is it? That's not working. Anybody have something different? What do you have, Noah? Okay, let's check that now. So I'm going to graph it. So it looks good from the graph. Looks like it has a 0 at 2 and a 0 at -2. Let me look at the table to make sure. So at -2, there's our 0, and a +2. So that is it. Okay, so that's the one that's going to have the zeros at 2 and -2. So he said x squared minus 4, and that's going to be shifted down 4 units. Noah, can you explain how you knew it would be that? How did you figure that out?
I just did the graph.
You just like kind of guessed and checked? Okay. Also, if we have a 0 of -2, guys, what would that have been as a factor? If -2 is a solution, what would it have been as a factor? In other words, if I wanted to get -2 as a solution, can you see how if I had x plus 2 equal to 0, wouldn't -2 be a solution then? Okay, so what if +2 has to be a solution? What would the factor have been? And then what about if you multiply this out? What are you going to get? X squared minus 4. See how there are a lot of different ways of thinking of this one problem. All right, so now what about the g function? The g function. Anybody think they know what that one should be? What do you think, Jacob? Okay, so you're saying the g should be x squared plus 4. All right, so that's going to be a shift up 4 units. So it's going to look like that. So I agree it's not going to have any real zeros, is it? So now I can check it. I can say, okay, x squared plus 4 equals 0. I'm supposed to get zeros of -2i and +2i. Well, if I bring this over, I get -4. I take the square root, x equals, and then that's going to be plus or minus 2i, isn't it? So that is going to work because I get positive or -2i on that. I can't really check that on the graphing calculator, but I can check it algebraically. Any questions? All right, so one more. What if you have to get imaginary zeros of 4i and -4i? Raise your hand if you can tell me what the function would be. I need more hands. I got 2 people. 3. 4, 5. Jessica, what do you think?
Would it be x squared plus 16?
Do you guys agree who had your hands up over there? She's right, isn't she? So f of x equals x squared plus 16 would have those zeros of positive 4i and negative 4i. Okay, one more. This time you have to have zeros of positive 6i or negative 6i. You should see a pattern. I should see all hands up now. Hesitant hands. All right. Halima, what do you think? You got it. Okay. See the pattern? All right. Good job, guys. That's it for today. Pretty short lesson.